What are black holes and why are they created by the universe? Are they an anomaly? Can we ever be able to travel to other galaxies in our universe using the wormholes? Or is it only theoretical and it is not pragmatic, as humans could barely travel to moon or maximum to Mars as of now? So are we saying quite far in the future it is possible? What do you think?
So let me just briefly. So what I'm going to do is I'm actually just going to briefly define what black holes are, because the thing is that I think they're being misrepresented in the media quite a lot, and so I'm just going to clear up on some of those misconceptions, and then talk about why are they created, and can we be able to travel through other universe to other galaxies in our universe through wormholes and other stuff like that. Now let's start off with an example. Let's say you are a distant observer observing a black hole. Let's also say that I'm orbiting the black hole. I'm close to the black hole, but I'm not that close. According to your frame of reference, my clock appears to be ticking slower than yours, and this is due to gravitational time dilation from Einstein's theory of general relativity. A similar phenomenon actually happens on Earth, but just to a lesser degree. Now, let's say you throw something into the black hole, say your water bottle. And as the bottle races towards the black hole, it picks up speed, just like an apple falling towards the earth picks up speed. But that is, however, until the water bottle actually gets really close to the black hole. According to the water bottle's frame of reference, it passes over the edge of the black hole. But to us outside observers, it seems as if okay. So according to the water bottle's frame of reference, the bottle crosses the edge of the black hole. However, to us outside observers, it seems as if the water bottle actually slows down and then just hovers at the edge of the black hole, and it just doesn't progress after that point, even if we wait an infinite amount of time. This is freaky. According to outside observers, the bottle just doesn't progress after the edge of the black hole, which means that certain events in space-time do not happen in our frames of reference. But the weird thing is that a black hole is that set of events, according to the outside observers, that do not occur. Now, it's not a visibility issue that's causing, us to not be able to see those events. No, 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 no. It's because space-time is so weird inside black holes that those events simply are not seeable, simply do not occur in our frames of reference. Now, the edge of the black hole is defined as the event horizon, and this is because the last event to which we outside observers can assign a when is on the event horizon. And this is just a really weird and freaky thing, because usually you tend to think of black holes as really massive objects. But if black holes are really massive and really heavy, then where does that mass even come from? Does the events inside the black hole somehow mimic mass, or do they actually have mass? Now, this is a big problem, because the thing is that nobody actually really knows where this mass comes from. The thing is that in Einstein's theory of general relativity, there exist idealized black holes, or black holes with simplified physics, and such black holes are in virtual mathematical universes which do not have any matter in them, even in the black hole. And so if we are to come up with a definition as to where the black hole's mass comes from, then it should not only apply to realistic black holes, the ones which we see in our universe, but it should also apply to these idealized black holes. Now, let's move on to some misconceptions about black holes. Now, the first is that black holes suck stuff in. That's not actually true. If you replace the sun with a black hole, then Earth would orbit it just fine. That is, if the black hole had the same mass as the sun. Now, the reason why I believe this misconception came to be is that, it's just the fact that, once you're inside the black hole, you can never really actually get out. And I think, and the best way to explain why this is true is because the space-time inside a black hole is so weird that simply going back out is not an option. Space-time actually descends into the black hole faster than the speed of light, and it descends down into something called the singularity. and this is why stuff cannot go outside a black hole. If you had like powerful rockets and stuff like that, you could totally hover on the at the edge of a black hole, or even just a little further out. The Earth, as I mentioned, can orbit a black hole just fine. So yeah, this is just one of the misconceptions which I see a lot. Another is that, like, black holes are black because not even light can escape their gravitational pull. I think this misconception is sort of a little bit more subtle, and I feel like it's there's actually a slightly different reason as to why that occurs. It's just that when you've got like an object going into the black hole, as it slows down and hovers over the edge, that light is actually stretched out so much by the black hole's gravity that it's basically invisible to us. And so
Mm.
when I was mentioning that the water bottle would hover above the black hole and we would never see it progress, we would actually see the water bottle slowly turn red and then invisible because of that red shift. Also, just another misconception is that the singularity of the black hole is infinitely dense. Nothing can be infinitely dense in space-time. In fact, the singularity could just be thought of as a hole in space-time. So if space-time were paper, like, an A4 sheet of paper, then the singularity would be a hole in that paper. Now, there are various different kinds of black holes, ranging from stationary black holes or Schwarzschild black holes. There are also rotating or charged black holes, supermassive black holes, black hole mergers, and so many, many, many more. And these black hole mergers can be seen through gravitational waves. Now, you can represent black holes in diagrams called space-time diagrams, and all the events around black holes can also be represented using those diagrams. And these are similar diagrams to, your XY grid. And so on the x-axis, you've got like your time, and on your y-axis, you've got one dimension of space. But there are other ways of representing black holes, and one example of that is actually a Penrose diagram. And a Penrose diagram can describe space-time, and when you do the geometry of, like, showing a black hole on a Penrose diagram, and you do a little bit of math, you figure out that, the Penrose diagram is slightly incomplete. It feels as if, the Penrose diagram needs to be expanded upon. And what you find is that you find that on the other side of the black hole, you actually find a parallel universe. And, and then you also find a white hole fitting that Penrose diagram, which is just absolutely insane. And this is where wormholes come into play. Now, the
Yeah.
problem is that wormholes and white holes, frankly, probably don't exist. And the reason why is because wormholes need negative matter or anti-gravity to keep themselves open without them collapsing in on themselves. The same thing goes for white holes, and so these are just purely theoretical mathematical objects that just came out of Einstein's theories. With Einstein's field equations, which, determine how space-time should curve when there's matter around it, and how matter should move when space-time is curved. Not only can you just solve the Einstein equations traditionally, but you could just come up with your own solution and then work backwards to see what conditions you would need in order for that solution to come
Mm.
out to work. And so that's what Alcubierre did. He actually did that for the Einstein field equations and found that you could create an Alcubierre warp drive. But the problem is that wormholes just don't exist. They probably don't exist, and even if they do exist, they would cause, one, time travel paradoxes, two, insane amounts of Hawking radiation, and three, they would require negative energy or negative matter or anti-gravity, whatever you want to call it, which just doesn't exist.
Mm.